This video will cover Chapter 3, Section 1, Graphing Quadratic Functions. Now, we've already graphed some quadratic functions back in Chapter 2. In Section 1, when we were graphing linear equations, square root equations, and we graphed some quadratics. And they look something like y equals x squared plus 1. Alright, and remember we found the vertex and then chose some points based upon what our vertex was. Now the difference in what we're going to look at today is that in those that we graphed earlier, that was just the parent function plus or minus a number. So we were missing the b term, the middle term, and the coefficient was 1. The ones we're going to look at today are going to have the b term, and there may be a coefficient other than 1 on our x squared. Okay, so if you think back to when we talked about graphing those quadratic functions, we said that the graph of a quadratic function is a parabola, and they are symmetric with respect to a line, and that line is known as the axis of symmetry, or we may just call it the axis of the parabola. And the point where the axis intersects the parabola is the vertex of the parabola. So this axis of symmetry runs through the middle of the vertex, all right, through the middle of the parabola. And if you took and folded your parabola down this imaginary axis of symmetry, then each side would match up, all right? And so that makes the parabola symmetric, meaning points that are the same distance or that are a distance on the left from the axis, there's a point that's the same distance on the right of the vertex. All right, if you're looking at the direction in which the parabola opens, when A is positive, then your parabola should open up. All right, remember A is the coefficient of that x squared. And then if your A is negative, your parabola should open down. All right, now there are a couple different ways you can graph quadratic functions. We're going to use a way where you find the vertex, the x-coordinate of the vertex, plug it in, and then choose some points to the left and right of the vertex. There are other ways, but we're going to stick with this way for now. Okay, to find the vertex, remember you take the opposite of b. Remember, b is the number in front of the x term. You divide it by 2 times a. Remember, a is the coefficient of the x squared. Okay, then you take that x value, plug it back into your function to find the y coordinate. That will give you the vertex. All right, once you find the vertex, you're going to choose 2 values to the left and right of the vertex. So however far you go to the left of the vertex, you're going to go that same distance to the right. All right, and when you do that, those values, x values, that are the same distance from the vertex, they have the same y value. Okay, so let's take a look at this first graph here. It says x squared plus 4x minus 4. So first thing I want to do is find the vertex. All right, I need what is a and what is b to find that. All right, remember a is the coefficient of our squared term, and that would be 1. And b is the coefficient of our x term, and so that would be 4. All right, now if I take that information and fill it in to my vertex form, all right, we'll have x equals the opposite of b over 2a. All right, our b is 4, so the opposite of 4 is negative 4, and then we have 2 times 1. So negative 4 divided by 2 would be negative 2. All right, and that is the x-coordinate of our vertex, and I'm going to write it up here in the middle of my table because I want the vertex to be in the middle, and I'm going to pick some points to the left and to the right. All right, so first I'm going to pick my x values, and then we'll go back and plug them into f of x to find what our y is. All right, so my vertex is at negative 2. If I go 1 point to the left, then I will be at negative 3. All right, and since I went 1 to the left, I'm also going to go 1 to the right. So if I'm at negative 2 and I move 1 place to the right, I'm at negative 1. All right, so since negative 3 and negative 1 are the same distance from -2, they should have the same y value. That means I only need to plug in one of them back into my function to find the value, and once I find one, I have the other. Alright, now from -2, I'm going to go a distance of 2 to the left, so 1, 2 will put me at -4. And then if I'm at -2 and I go a distance of 2 to the right, 1, 2, that puts me at 0. So -4 and 0 should have the same y value when I plug them in. So I really only need to plug in one of them. So essentially you're only plugging in three numbers to get your 5 points. Alright, so let's start with the vertex. So I'm going to plug the vertex, so I'm going to find f of -2. So into my function, x squared plus 4x minus 4, I'm going to replace all the x's with the -2. Alright, remember if it's a negative, you want to go ahead and put it in parentheses, or you can just store the information in your calculator and let your calculator handle those negatives, and it knows how to handle them correctly. So you may just say -2 and store it in x. Alright, and then just type in your function x squared plus 4x minus 4. And that would give me a value of -8. Alright, so when x is -2, my y is -8. Alright, then I would do the same thing with -3, and then also once I find -3, then I also know the value of -1. So if I plug in -3, alright, which also you can use your calculator, which sometimes may be a little bit faster once you get the function typed in. So I would store -3 in x, and then just recall my function by hitting second enter until my function is on the calculator. Hit enter. Alright, -3 makes the function have a value of -7, so I'm going to plug that in there. That means -1 also has a value of -7. Alright, lastly I'm going to plug in 0, and you can do either -4 or 0, it doesn't matter which one, they should have the same y value, but it just seems that 0 would be easier. Alright, so 0 plus 0 minus 4 would be -4. Alright, now that we have our points, let's take a look at the function for just a quick bit here. Alright, the a is positive. Alright, so that means my parabola should open up, and my vertex should be the lowest point in that parabola. So once I plot my coordinates, I'm going to make sure that my graph matches that is opening up and that my vertex is the lowest point. If it's not, then I've either calculated wrong or I've graphed wrong. Okay, so let's go back down here. I'm going to plot my vertex first. So at -2, -8. Alright, all my other coordinates should be above that. Alright, so then we'll do -1, -7, and -3, -7, -4, -4, and then 0, -4. Connect my coordinates in the shape of the parabola. Make sure to put arrows on each end. Alright, let's look at the next one here. Alright, for B, we want to graph f of x equals -3x squared plus 24x minus 46. Alright, so my a is negative. That tells me that my parabola should open down. Alright, and that my vertex should be the highest point. Let's get my a out. So a is -3 and b is 24. We're going to plug those in. Alright, so for my vertex, this is the vertex. The x coordinate of it is going to be the opposite of b. So that'd be -24, and 2 times a. So I'll have negative 24 over negative 6, which is 4. So the x-coordinate of my vertex should be 4. I'm going to write that in the middle, and then I'm going to pick 2 points to the left and 2 points to the right that are the same distance as those to the left. Alright, so if we're at 4 and I go 1 to the left, that'll put me at 3. And if I'm at 4 and I go 1 to the right, that'll put me at 5. If I'm at 4 and I go 2 to the left, that'll put me at 2. And if I'm at 4 and I go 2 to the right, that'll put me at 6. Alright, then 3 and 5 should have the same y, and 2 and 6 should have the same y. So I only need to plug in one of each pair. So the first thing I'm going to find is f of 4. Once again, I would probably just let my calculator handle this, but I want you to see what I'm doing. Alright, so we're going to plug in everywhere there's an x in our function, we're going to plug in a 4. Alright, so if I let my calculator handle it, I'm going to store 4 in x. Then just type in my function, negative 3x squared plus 24x minus 46. And that gives me a value of 2. Then I need to pick one of each pair, so I'll pick 5 this time and also 2. So that's one from each pair. Alright, so let's plug in the 5. So everywhere there's an x, we'll put in a 5. I'm going to use my calculator to do that for me. Alright, and I get negative 1. That means also that when x is 3, y is negative 1. Alright, lastly we'll do 2. So everywhere there's an x, I'm going to replace it with a 2. I'm going to let my calculator do these calculations here. So I'm going to store 2 in x, recall my function. Alright, and I get negative 10. So that means that also when 6 is x, y is negative 10. Alright, let's put it on our graph here. I'm going to start with my vertex. My vertex should be the highest point this time. Alright, so I'll go right 4 and up 2. And then I'm going to go right 3 and down 1. And then I'm going to go, let's see, right 5 and down 1. And then right 2 and down negative 10. This is a very skinny parabola. Alright. And then make sure you connect your coordinates in the shape of a parabola. Make sure to put arrows on each end.